two polynomials. Such a rule is called division algorithm. If fx and gx be two polynomials of degree n and m respectively, where n is greater or equal to m, then there exists two polynomials qx and rx such that fx equal to gx times qx plus rx, where degree of qx is equal to n minus m, that is degree of fx minus degree of gx. Also, the degree of rx is less than m or greater than 0. In this, fx is called the dividend, gx is called the divisor, qx is called the quotient, and rx is called the remainder. This is exactly the same what you have done in division of two polynomials. When we divide fx by gx, we get quotient qx and the remainder fx. We must recall that rx is always of degree less than the degree of gx. However, if rx is equal to 0, that means the remainder is 0, then we say that gx is a factor of fx. In that case, fx contains two factors, one of them is gx. Now we define a polynomial equation. If px equal to a0 plus a1x plus a2x square plus so on an x raised power n, where n is not 0, be any polynomial of degree n, then px equal to 0, that is a0 plus a1x plus a2x square plus so on plus an x raised power n equal to 0 is called a polynomial equation of degree n. Consequently, 3x plus 5, 2x square minus 5x plus 5 equal to 0, 2x cube minus x square plus 5 equal to 0, and x raised to power 4 minus 7x square plus 5x plus 1 equal to 0 are all polynomial equations of degree 1, 2, 3, 4 respectively. If it is of degree 1, it is called linear equation. It is of degree 2, it is called quadratic equation. If it is of degree 3, it is called cubic equation, and if it is of degree 4, it is called quartic equation. After defining what is a polynomial equation, we now go over to defining the root of an equation. If fx equal to 0, that is a0 plus a1x plus a2x square plus so on an x raised power n equal to 0, be any equation, then alpha is said to be a root of this equation, that is px equal to 0, if and only if p alpha is equal to 0. That is, when we substitute alpha, it makes it 0. That is, a0 plus a1 alpha plus a2 alpha square so on an alpha raised to power n is equal to 0. Note, 0 of the polynomial fx is the same as the root of the polynomial equation fx equal to 0. Further, we discuss factor theorem. What is the factor theorem? If alpha is a root of the polynomial equation fx equal to 0, then x minus alpha is a factor of the polynomial fx, and conversely. To explain the factor theorem, let fx equal to 0 be any polynomial equation of degree n. Then fx is a polynomial of degree n. By division algorithm, take gx equal to x minus alpha. We get fx equal to x minus alpha into qx plus rx. We have used division algorithm. Clearly, degree of rx is less than the degree of the divisor x minus alpha, which is of degree 1. Therefore, degree of rx is less than 1. Hence, it is a constant. Therefore, Rx is a constant. Let Rx be equal to R. Substituting, we get Fx equal to x minus alpha into Qx plus R. If alpha is a root of Fx equal to 0, that means f alpha equal to 0. Putting x equal to alpha, we get f of alpha is equal to 0 plus R. But f of alpha is equal to 0 means R is equal to 0. When R is 0, Fx is equal to x minus alpha into Qx. Clearly, x minus alpha is a factor of Fx. Conversely, if x minus alpha is a factor, then Fx is equal to x minus alpha into Qx. If we put alpha, x equal to alpha, we get f of alpha is equal to 0, showing thereby that alpha is a root of Fx equal to 0. That proves the factor theorem.